Okay, let's jump right into this explainer. Today, we're going to put your perception to the absolute test to see if we all truly experience the same reality. We basically go through life assuming our eyes are just these objective little cameras, right? Just simply recording the world exactly as it is. But as we're going to see, the fascinating science of perception proves our brains are actually doing a whole lot of behind-the-scenes editing that we don't even realize.
I mean, you'd probably assume that when we both look at the color orange, we're seeing the exact same hue. But our minds might actually be playing completely different tricks on us. When we look at an optical illusion together, it feels like this universal trick we're both falling for. But the truth is, what's happening inside my head when I look at an image might be entirely different from what's happening in yours. So, do we truly experience the same illusion? Well, let's find out.
Section 1. The Duck-Rabbit Test.
Let's start things off with a super famous psychological illustration. This was created way back in the mid-1800s by the American psychologist Joseph Jastrow. Now, this image allows for both interpretations. Some see a duck, others see a rabbit. But here's the catch. Switching between the duck and the rabbit actually requires active mental effort on your part. You can see the duck or you can see the rabbit, but notice how your brain absolutely refuses to let you see both animals at the exact same time. You literally have to force your perspective to shift. And that proves right out of the gate that seeing isn't just some passive activity. It's a highly active construction process happening right there in your mind.
Section 2. The neuroscience of perception.
So the really crucial point here is understanding why our brains process these seemingly simple images so differently. And to get to the bottom of that, we need to fast forward from 19th century drawings to modern neuroscience. Think about those classic optical illusions. When researchers asked participants to judge the size of two identical circles that were placed in a tricky visual context, it was almost impossible for anyone to accurately see them as equal. Even when you're told factually, hey, these two circles are exactly the same size, your brain just stubbornly overrides that logic. It absolutely insists on being tricked. So researchers set out to uncover the mechanics behind this. They wanted to know why some people fall for these illusions way harder than others.
To figure out why we get tricked like this, scientists actually used fMRI machines to map out the visual cortex. If you're not familiar, that's the specific part of your brain responsible for processing visual information. It's essentially your brain's headquarters for taking in light and translating it into the world you see around you.
Now, this is where it gets wild. It turns out that the physical size of your visual cortex directly dictates how easily you're fooled. Researchers found that participants with a physically larger visual cortex were actually better at judging the true size of those inner circles. On the flip side, those with a smaller visual cortex were the least accurate and were easily tricked. And this wasn't just some random one-off finding. Researchers came to the exact same conclusion when they tested people using other optical illusions too.
Which naturally leads us to a pretty massive question. Why does brain size dictate perception? Why would the physical dimensions of one specific brain area make someone more susceptible to visual tricks? Well, while it's tough to say with absolute certainty why the size of this one area leaves people more easily tricked, researchers do have a really strong biological theory.
It turns out that alongside physical size, the answer may actually lie in the concentration of chemical messengers inside the visual cortex. It seems these internal messengers might further alter our subjective visual experiences. Just think about that for a second. It's an incredible combination. It suggests that your very own personal experience of visual reality is being heavily moderated by the unique chemical makeup sitting inside your specific visual cortex.
Section 3. Context, Culture, and Brains.
But it isn't just our internal biological hardware making the rules here. Our external environment is basically writing the software. The things we see can be constructed in so many different ways, and it turns out the magnitude of these optical illusions actually differs across diverse groups of people. For instance, studies have found that people with autism experience the magnitude of optical illusions differently than neurotypical people. But get this, it also varies widely among people from completely different cultures. This tells us that your surroundings and your unique neurodevelopmental path all play a massive role in how you perceive a simple drawing.
And nothing brilliantly illustrates this better than our old friend, the duck rabbit. It turns out that exact same mid-1800s drawing is interpreted completely differently by children, depending entirely on the time of year and the holiday context. Seriously. When children were shown that classic illusion on Easter Sunday, which is obviously prime rabbit season, way more of them immediately saw the rabbit. But on any other regular Sunday, they were much more likely to see the duck. And if you show it to them in late November, right around Thanksgiving, they might even view that duck through the lens of turkey season. The context completely primes the brain to construct exactly what it expects to see.
Section 4. Your unique reality.
All of this data proves that the old saying, "what you see is what you get," probably needs a major scientific update. We are clearly constructing a whole lot more than what is actually printed on the page. Whether we're judging the size of circles, figuring out the length of lines, or trying to spot a pod of dolphins splashing around, our perception is just aggressively filtered through this huge list of biological and environmental lenses. Your visual cortex size, your chemical messengers, whether you have autism, your cultural background, and even the current holiday season, they all act as these powerful, invisible filters constantly altering your subjective experience.
It all comes down to this. Things may be perceived through different lenses. Because our brains construct what we see in so many incredibly different ways, the duck I see might truly never be the exact same duck that you see. Even if we're standing right next to each other staring at the exact same image, our brains are essentially placing us into entirely different realities.
So as we wrap up this explainer, take a quick look around your room and ask yourself, how much of your daily reality is uniquely yours, shaped entirely by your own visual cortex? What other realities are you perceiving completely differently from the people sitting right next to you right now? It's a pretty wild thought, right? It's just an incredible reminder to keep an open mind, because the world you see is really just one out of billions of possible interpretations. Thanks for exploring this with me today, and keep questioning what you see.